Hi, I'm Old Norse Specialist Dr. Jackson Crawford, and over the years on this channel, I have often featured fossils and dinosaurs, and I was delighted to hear about the naming of Lokiceratops, a great Venn diagram of my interest, right? So to talk to us about Lokiceratops here at the Natural History Museum of Utah is Savhannah Carpenter, a paleontology researcher who has done extensive work on this fossil. So can you first of all tell us where is this from? When is this from?
Yeah, so Lokiceratops was discovered in northern Montana. It's from the Campanian Age Judith River Formation. And we just discovered it a couple years back. It was just published about 6 months ago.
By, among others, you.
Yes.
So tell us a little bit about this animal and how it has you said that it had somewhat redefined our understanding of ceratopsian relationships. Where does it fit in that ceratopsian family tree?
Yeah, so we have two major groups of ceratopsian dinosaurs. We have the Chasmosaurus and the Centrosaurus. Previously, we kind of believed that there would only ever be two ceratopsians living alongside each other, so one Centrosaur and one Chasmosaur. This kind of changed that. We've been finding a lot from the Judith River Formation in Montana, and this actually rounds out four living alongside each other within the Centrosaur group. So we kind of are learning that there's a lot more radiation throughout ceratopsians than we previously realized. We were able to do a phylogenetic analysis, basically a family tree, and discovered that it is a cousin of Medusaceratops and Albertaceratops, which are also both from that area of Montana.
You know, one thing that I think about, there are several related animals living together in the same ecological niche at the same time. I mean, the closest analog I can think of is probably in a place like northern Montana today, where you have elk, mule deer, white-tailed deer if it's expanding into the area, antelope. I mean, are they specialized like that in terms of diet or maybe environment? Or can we tell? Is there any indication of why there's so many animals of the same rough kind?
Yeah, that's definitely kind of like a future thing for us to kind of study a little bit more of. They do have subtle differences in their teeth, which would suggest subtle differences in their diet. But generally speaking, they're just getting as showy and flashy as possible, basically because it was sexy.
I guess that is the theme with the heads of browsing animals, actually. It's interesting, the convergent evolution about that, isn't it? What is the difference between Centrosaurus and Chasmosaurus, was it?
Yeah, Centrosaurus, Chasmosaurus. Centrosaurs generally like to have a shorter frill, and they get a little crazier with the nose horns, which is interesting because Lokiceratops is a centrosaur, but it's completely lacking a nose horn. So that is kind of unique for its family. Chasmosaurs are like Triceratops. They like to get really big frills and really crazy with those brow horns.
I see. So are these animals probably like... You know, I just thinking about the diversity in these, which there's a wonderful exhibit here at NHMU, this wall of ceratopsian heads that really shows you the abundant diversity in this family. Are these really short-lived species? Like, is it that they radiate into these weird forms that die out in their little tiny niches rapidly, or do these persist fairly long?
Yeah, that's a great question. So they are definitely radiating and changing species really, really quickly. The average runtime for any one of these species is only about 1 million years. So they are changing really quickly and then moving and getting new species.
Mm-hmm. All right, and a little bit more about this animal itself. So what is probably the total length in life?
Like as far as lifespan goes?
No, like how long is it?
Oh, how long? About 22 feet. Yeah, really large. Is the largest herbivore of its ecosystem. Weighed probably about 5 tons in life.
And what other animals is it living alongside beside those other ceratopsians?
Yeah, so like I said, there's those 4 ceratopsians living alongside it that are centrosaurs. There's also one chasmosaur that it lives alongside. And then a few small theropods that were running around in that area as well, like Displestosaurus.
Okay, and that's a tyrannosaur?
Yes, I believe, yeah, large or small tyrannosaurid.
Okay. And do we know anything about its life history? I mean, how old of a specimen this is? Do we have any hints about that kind of thing with these animals?
Yeah. So aging a dinosaur is kind of tough. We rely on histology, which is where you like chop bones into little slices and count the rings, kind of like on a tree. And so from that, we've learned that dinosaurs probably lived to like up to 30 years, maybe. The problem with doing that type of histology is we don't have a modern animal to compare it to. And so, it's tough to say, do they get an annual growth ring? Does it slow down or speed up once they hit maturity? And so it's kind of guesswork. And then, looking at modern animals and their histology to compare. But yeah, about 30 years is a probably pretty good estimate.
And is this an adult?
Yes, this is definitely an adult dinosaur. Like I said, really, really large and fully developed skull and fully developed teeth and all that jazz. So yeah, maybe up to 30, perhaps.
All right. And the Campanian, how old is that?
Yeah, so the Campanian is a stage in the Cretaceous. About 78 million years is where we've dated this guy. Sorry.
All right. Low-tech YouTube. All right, well, thank you very much for that intro to the animal. Will you share any particularly interesting facts from your research that I might have missed?
Yeah, so besides just the exciting revelation about the radiation and realizing there's a lot more ceratopsians living in one place at one time than we realized, it's also kind of a record breaker. It's got the largest horns on any horned dinosaur ever.
The brow horn?
The brow horn. Well, not the brow horns. They're actually called epiparietals, those big blade things on the back of its frill. And it's also the largest centrosaur to ever live. So lots of really cool things about this particular dinosaur.
And you said the species name is Rangiformis, so reindeer.
Yes, Rangiformis. Yeah, reindeer. We definitely notice it's very asymmetrical with those epiparietals there, and that's something we do see in nature with caribou and reindeer and things like that. And we do think this is how it was in life. It was actually asymmetrical.
Interesting. And again, interesting the sort of parallel evolution with grazing animals today.
Yeah, absolutely.
Well, thank you so much for your time.
Yeah, thank you.
And to those out there who might have the opportunity, come to the Natural History Museum of Utah to see this fossil, see a lot of other great fossils and great exhibits, including, I really like the Ceratopsian wall. And for now, from beautiful Utah, we're wishing you all the best.